Well, hello, wonderful class. We meet again. Today, I'm extremely excited about today because we're going to add and subtract radical expressions, okay? But it's going to be a little bit different than the last one. The last time we did it, maybe you saw that video, maybe you didn't. But either way, I want you to look at this right now. We're going to do 3 problems. The first one, I'm going to do for you. The second one, I'm going to encourage you to pause it and attempt it before I finish it. And then the third one, I really want you to try to do on your own. Of course, I am going to go over the solutions to that one as well. So let's do the first problem here. We have 2 and a root, or radical 6 minus 2 rad 24. Now, this minus that. Now, the first thing is, we can't just say 2 minus 2, because these aren't like terms. Because 6 isn't 24. Last time I checked, the number 6 was different than the number 24. The last time I needed to punch 6 into my calculator, I pushed a different button than when I wanted to push 2-4. In order to hit 2-4 on my calculator, I got to hit the button 2, I got to hit the button 4, and neither one of those buttons are 6. So these are different terms. So we can't just subtract them. We just simply can't say 2 minus 2 is 0, okay? And here's where the beauty comes in. Here's where the creativity comes in. You see, a lot of people look at 24 and all they see is, well, that's the number 24. There it is. Beautiful, but there it is. That's all it is. But we get a little bit creative here, and sometimes we don't appreciate exactly how creative this is. We look at the number 24 and we realize, you know, that's actually 12 times 2. That's actually 6 times 4. I mean, I don't know what you want to say. Maybe you want to say it's 25 minus 1. I mean, we can represent 24 in a variety of ways. And one of these ways is going to be very useful. I'm liking this one, the 6 times 4, and I'm going to tell you why. Watch. 2 root 6 minus 2. But here's what I'm going to say. It's not 24 anymore, because 24 is 6 times 4. And I'm going to put the 4 first, so 4 root 6. I'm liking this. This is making me excited. And I'm glad it's making all of you excited. It's actually really quiet in here. It's almost like the room is empty or something. But anyways, look at this. I got a 6 here and I got a 6 here. So in my mind, I'm thinking, good. I'm seeing like terms and I'm getting excited about that. And I also know a little something about the square root of 4. Look, I got 2 root 6 minus 2 times 2 root 6. Here's that 4. That 4 became that 2. Now, I'm just going to keep on simplifying. This is staying the same. 2 root 6 minus 2 times 2 is 4 root 6. Now we got like terms. Right here, they're both 6. They're the same value. Now it's the same as if I was just rocking 2x minus 4x. And I was sitting here telling you that's negative 2x. Because these are like terms. So are these. 2 minus 4 is negative 2 root 6. Bam! That's the answer. That's how we do it. Okay? We see initially that they're not like terms, and we're not okay with that. I'm going to make you be a like term. And maybe you can't, but we're going to try. And look what happens. 4 times 6. Uh-oh, I see some like terms. 4 goes to 2. Bam!
Come to the main office.
Oh.
Peter Kelly, please.
Peter to the main office.
office.
Is Peter in here? Peter to the main office. Okay, so we get down here, negative 2 root 6, and that's the answer. That's how we do this first one. All right, let's move on to number 2. Of course, if you didn't get all of that, you can always hit rewind. Number 2. Now here's the one where I'm kind of hoping perhaps that you jump ahead, and maybe you hit pause after you see me write this, and you give it your best shot. Okay, so plus 3 root 54. All right, on your piece of paper, if you're taking notes, why don't you just hit pause right now and try that problem. But I'm going to explain it anyway. In fact, I'm going to bring an orange marker, because that's how I roll. Look, root 6 and 54. 6 and 54 are different numbers. These are not like terms. You can't just say 2 plus 3. But you also can't just give up and say, well, they're not like terms. Oh, well. You got to try. You got to use your intuition to say, no, I see a relationship here. I'm going to find it. I'm going to make these like terms. 54, watch this. I mean, I see it, and I already kind of go to the answer. Maybe you don't know what it is. Well, then look. Write this, 54. Figure out what all your factors are. Oh, why did I pick such a big number? What is that, 27 times 2? Oh, 9 times 6. Oh, yeah. Yeah, I think we got something. I think we got something. And I'm double excited because 1, it's got a 6, and 2, it's got a 9. And 9 is a perfect square. Look. So, I know a little something about the square root of 9. I know it equals 3. So I'm going to show that now. 2 root 6 plus 3. The square root of 9 is 3. So I got 3 times 3, root 6. Now I'm going to get that up there. So we got plus 9 root 6. Now we have got like terms. Now we're in business. Now we know how to roll. You simply add the number in front of the like terms. So, 2 root 6 plus 9 root 6 gives me, I don't know why I switched that out, let's switch to the black marker, 11 root 6. This is just algebra, people. That's all this is. This is the step right here. That's the big step. Right there. That's the beauty. I hope you're getting this. I hope you're getting this. Good news, we still got one more problem to do. All right? Get this written down. First of all, does anybody have any questions? I hope not, because I can't actually hear you. But if you do have questions, I imagine there's... You can ask your teacher or something along those lines. I don't even... Oh, here we go. Here we go. All right, last problem. This is the one I really want you to step up and say, do I get this or do I not? And here it is. Problem number 3. Problem number 3. We have 3 root 3 minus root 27. You got this. Don't wait for me. That's the thing. If you wait for me and I just give you all the answers, you're going to think you got it, but in actuality, you don't have it. You only learn from failing. So try this. Get it wrong. I don't care. Just try it. And then listen to my solution. That's the way to roll. Okay. Let's do this thing. Last problem. Oh man, it's been a good day today. It's good to end with a nice solid problem. A nice math problem that has a nice solution. I mean, maybe it does, I don't know. The goal is to simplify this. Alright, so we got this thing. It doesn't make a lot of sense to me. I look at this number, I don't have much intuition of what its value is. And simplifying is gonna help that. So, this is root 3. We want to try to make this have a root 3. Because 3 and 27 ain't the same number. So you can't add them because they ain't like terms. But 27, we know a little something about 27, is that that's 9 times 3. Right? If you rock 27 here, you got 9 times 3. So let's see what we got. So we got 3 root 3 minus not 27. I'm not going to write 27 because I'm representing that as root 9 times root 3. The square root of 27 is equal to the square root of 9 times the square root of 3. Boom, boom. Yeah, this is good. That's a good sign. That means we're getting there. If you're taking a test and you see that you got the same number under the radical sign in 2 places, you should stand up on your desk and be like, I got this. I'm getting this. I think I got it. That's what you should do, because you'd be right. Because look what's going to happen. Square root of 9 is 3. 3 root 3 minus 3 root 3. 3 minus 3 is 0. Root 3. 0 times anything. 0. My friends, all this, I looked at this and I didn't know that it equaled 0 when I first looked at it. I had to simplify it. And that's the power of simplifying. I encourage you to go try some other problems now and enjoy the rest of your day. Cheers.